Hello. Now we will talk about digital requirements validation and verification process. So here we see straightforward workflow. So validation verification engineer set up test cases, executes test cases, and then the modeling environments can run the model simulations depending on what models we are executing, right? So for example, CATIA Magic can run SysML model, UAF model, right? But mostly, let's say, SysML model, and perform system level validation verification based on the test cases executed. Those test cases could be executed in CATIA Magic, but also could be an external environment executing this model remotely. So we are talking about remote execution through co-simulation, and we will talk about that. And once we execute that, we can actually run this as a workflow here, the simulation. See, executing test cases, running now different simulations, including SysML simulation, but also Multiphysics simulation and Dymola. Different requirements can be verified using speed of the, let's say in the robotic arm context, speed, power consumption, torque. Is this motor suitable to execute this scenario? And then kinematic simulation, like collisions of the updated robotic arm in the new environment, in the same environment or new environment, running the same test cases in the DELMIA robot simulation app. We can get that result, verification of the collisions, and then we capture results. Again, we can get that using the co-simulation environment. We'll talk about that out of the box solution. And we perform the requirements verification. So why do we need all those different environments and models? Because different requirements can be tested with different simulations. Now let's go to the architecture of the solution. So we are using co-simulation environment using the functional mockup interface, which is the standard, very popular Modelica consortium standard, used by 250 tools currently, and expanding. But the standard is used for models interchange and co-simulation. But what we are using it by building proxies, connectors, to connect tools and run co-simulation. So we are using Modelica device driver library, and this library can be used by Dymola, built-in in Dymola, or behavior modeling app in 3D Experience platform, and generate those, let's say, two functional mockup units, which are like based on this functional mockup interface. Those packages are generated, which can be added to the tool supporting functional mockup interface, and they start communicating using one of those communication protocols: shared memory, serial, MQTT, TCP/IP, CAN, UDP. So it's out of the box. We don't need other type of integration. We get bidirectional fast synchronization of the properties, linked properties. So as you can see here, one scenario when we have hardware interchange with CATIA Magic, then we interchange with the Dymola, let's say, targets of robotic arm, and then Dymola can set the actual physical behavior for the robot simulation, and can get back also results. We can get physics simulation results back to CATIA Magic from Dymola, and collision detection, let's say, from DELMIA. And whatnot, it's up to us. The core thing is that this standard is enabling communication. As you can see here in this environment, we have FMU supporting apps, like internal and external, like Simulink supports FMU, and then those proxies, like server, client, site, generated and added to those apps to communicate through that interface. Okay, now how that looks like. So first of all, how do we generate those functional mockup units? So here we have Dymola, and Dymola out of the box has this capability. So here we have two interface models, one and another one. Here you can see we have input, and then here we have UDP send. We use UDP interface here of communication protocol, and we can send using this port. You see I'm using this port, and then I'm receiving from another one on this port. So I can change, for example, here to 5, or maybe let's say, yeah, let's do 5, right? And then on the other side I'm sending on 5 and receiving on the same as previously sending. Okay, now I have those two interfaces. I can go to simulation, translate. Let's check which one was selected, the first one. Okay, simulation, translate, FMU. Let's say I will name it like A, and I get, in the moment I get interface generated, functional mockup unit generated. Okay, now let's go back and let's go to this one, next one, and again simulation, translate, FMU. I will call it B. Okay, in a minute it will be generated. Okay, done. I can go to commands, the command to find location of those in the working directory of Dymola. Can go here, search. So you can see here, those are here, one and second one. Now I can create new project and execute those FMI interfaces from scratch, functional mockup units from show how to execute them from scratch. I will just do with CATIA Magic, and then later I will explain how to do it with other tools. So here, block diagram. First of all, create the context. Sim context, and then drag those two. Okay. Where is that? Here. One. And attach to the project. You see I have those properties exposed. There are also internal properties visible. I don't need to expose them, not necessarily for me. I can monitor them actually during simulation, but for me it's just more important those right now. Okay, A, B, and A. Also attach. Why do I attach to the project? Because it's more convenient to distribute it. You know, it will always be going together with the project if I will add on Teamwork Cloud and so on. So now I can put it here like that, and then create simulation config, because I need time for FMU execution. Expert mode, simulation config, core. So here will be core simulation. And then I go to timing, start time 0. Step delay, step size, I can specify step size, for example, 100 milliseconds, step delay, let's say 100 milliseconds, time unit, milliseconds, close. Okay, and now that's it. I can run the simulation, and you can see here I get simulation time ticking, and those interfaces I can actually close console, close this one, move it here, and see that they are interchanging properties. So if I will change property here, you see it automatically updated here. If I change this property here, see it automatically updated here. Now if I change on another side, on B, see automatically updated here. So it's bidirectional, has inputs and outputs. So those two, they communicate, in my case using UDP interface, and they can be added into other tools and establish communication with selected step size. In my case, it's 100 milliseconds, could be 50 milliseconds, whatever is needed. Okay, so that's how we create them. Now let's stop simulation and let's see how we are using them. And we will use them to communicate, first of all, with robot simulation application. So here we have robot simulation application. This robot simulation application, it is, you see here, full floor with multiple robots. Here we have one robot. See, welding robot, you know, those robots in robot simulation application by DELMIA, they can execute their own programs. So we can expand here and we can, for example, select it and run the program. This robot will execute. See, it's welding robot. It executes the program and performs the task, and we will see that it can interchange the information in and out using this FMI interface with external tools. So in our case, let's say CATIA Magic, we will be able to integrate the simulations. So let's go to our model. Where is that robot? In my case, it is here. Okay. Now I will go here. I will take this robot. You see here, it has its own program. Here we see this robot has its own program. You see, like it executes by itself, and will trigger that program. But also, it can listen to the external commands. And how it listens, you see here is FMU interface. FMU added one of those we just generated, and it's mapped here. Let's check. Here we have, you see this is mapped here to this robot. Okay, now I can select this one, task to execute, and I can run this. Okay, robot executed, but no visualization, nothing happens, right? Why is that? Because CATIA Magic is not running. So let's switch to this model. And in this model here we have, so you can see model where we are controlling multiple digital environments, including the hardware here, but also DELMIA robot simulation, Dymola physics simulation, through those FMU interfaces, and also do the requirements verification. This is just purely parametric verification, but we can do also feedback loop and do the verification directly coming with the data coming from those external tools. Interface allows that. So, okay, so I will run this, and now I can switch to the automatic mode. It will run through state machine and will update the robot movement. So you see those out of the box. This works, right? I can monitor property changes here. Can expand FMUs to FMUs. This is actually getting values from robot simulation application, and I can get verification. So I can switch to manual mode. You see, can move my robot. Can move my robot to the desired position. Can do this here. And if I move it here, you see, like I would collide. So can I detect those collisions? Yes, I can detect that collision. To do that, I need to go to the analysis here, fault monitoring, add new object, and from now on I'm monitoring the collisions. See here in this view, I will monitor. Again, I need to execute this robot simulation. It stopped once I triggered this analysis. Okay, it's now running. I can again switch to the automatic mode, but just to see, like, okay, it's running. But now if I will move robotic arm lower, here you see it's immediately detected collision. If I move again, you know, there is no collision. Again, collision, no collision. I can actually go to the collision mode, move it to the side. Okay, no collision. Go back, again, collision detected. So that's pretty much how it works. And was the robot simulation, and those results, you know, they are captured here. We can export to the log, but that's like in principle, that's every application can do specific analysis. And in our case, if we change robot arm shoulder length, we run through the scenarios, same scenarios we have, and we get results. Another thing that we can control this robot just to triggering the simulation. We don't need to program it or manually move it. I can just change this property and it will trigger the program. So I can program this, connect one of the properties that they would trigger the desired programs, like here, for example. If I double click on this task, I will switch those off. Yeah, here go. There's loop. If true, and this property is connected to this last property value. So now if I will run the simulation here, again, I need to run the simulation because I was opening the dialog. Okay, simulation running. And now if I will move this one to 1, it will start triggering the behavior, you see. The behavior is based on the program here. No more simulations running. I can switch on and off the tests, which would be programmed here, but control from the central environment, running the test cases externally. Okay, that was a great simulation, demonstration of robot simulation in the loop. What about multiphysics simulation now? So I can switch off this simulation and let's go to the Dymola graphics. We have this model here of robot simulation. Again, we have this robot arm which can execute. Here, what kind of simulations I can do here? I can, for example, change the servo motors. You see here I have a list of those motors. I have high torque, high speed, medium torque. For example, let's take medium torque motor, and then here I have a functional mockup unit which takes inputs from CATIA Magic in my case, and outputs again back results, and I can run simulation. So go to simulation, setup, go to the real-time true, okay, go to the translate, not translate but simulate. As you can see, very straightforward to run those models from scratch. You just need to click on the buttons, and all of them can be automated execution, right? So externally. Now here we have the execution done, and I can filter to the voltage. Let's track voltage. So let's do the EMF V in this chart, and then axis to motor EMF V, and axis 3 motor EMF V, and axis 4 motor EMF V. Okay, now I'm tracking that. I can actually concentrate on this more narrow view here. I can move it here, and if I will go to automatic mode, you see it's now moving, and once it moves, I see each axis different color moving. If I want to see manual, I can switch to manual mode, and let's say I've moved this one, you see it's blue. right? Now if I will move this one, see it's red, this one, see green. So it reacts to each axis, but also it sends back the feedback loop, so I can actually track, like, because with CATIA Magic I set the target coordinates to the DELMIA to run the physics simulation, and it gives back results. So I can minimize this. Let's go and set up the tracking of the feedback loop. So I have here this joint, selecting containment tree. This not the joint, but this is the chart of the joints. I will duplicate it, drag it here, and then from here I will track this, let's say FMI, which communicates with physics simulation, and I will track just two properties, so this and this. So this will set the target, and this will give feedback loop, you know, what is the actual physics-based position. And then, okay, here I will not use the previous chart. I will use the new one. Okay, so we execute, and now we can track the changes between the values. As you can see here, we have target and we have result with some calibration data in the loop. Let's move this axis, because we are tracking the axis number 1, you know. So we see the feedback loop coming, and now we can check the requirement that the distance between A and B, you know, between the input and output is less than some percentage, and like at all time, or something else, you know. So it's quite simple requirement check because of that feedback loop and because of the information what we are setting, you know, as a goal for this test case. So we can run through the different scenarios and we get results. So we can run automatically, and because we are tracking just this property, you see we get results through the scenario executed, you know, in our case is in this state machine, changing the inputs, and this coming back from Dymola. So blue line is CATIA Magic setting the targets, and the red line is Dymola based on physics model setting the physics-based response of the robot, which can control the physics, the robotic simulation, but also can do the requirements verification. In this case, it's how this corresponds. Okay, that was it. You know, we demonstrated multiple tools and how to connect them for the virtual requirements validation and verification process. Hope it will make value for you, and let us know what would help with adoption.